today's topic is the last topic of module 4, that is regression analysis. As I told you earlier, that I shall be taking one examination, CA2. Once I finish my topics of module 4, and the CA2 will be based upon the topics of module 4 only. Added chapter will be Chebyshev's inequality, because Chebyshev's inequality was earlier not set as a question in CA1. Okay, so that thing will be there. I shall give you some time. You start preparation, because before the examination, before one, I shall give you notification about that, and we'll get 1 week time for your preparation. But you start doing so, because once I finish my topic of regression, the countdown will begin. And so you just, due to end semester examination, you could not study properly the module 4 chapters, which were earlier discussed. So you recapitulate the things once again, you go through my videos, and you just try to recall what we learned in module 4. And then I shall set one date, and through Google form, I shall take my CA2 examination. So with this, I'm going to start my today's topic. My today's topic is the last topic of module 4, and that is called simple regression analysis. And you see, interestingly, beside that, I have written something which is also very catchy, and it is called a path to machine learning. Now, machine learning is a new subject, and we are all fascinated by new subjects. Okay, but while doing so, we forget our old ones, the old friends. When we meet new friends, we forget our old friends. Regression is our old friend. Machine learning is a new friend. But we don't know that these new friends, this new friendship can be made only if you can maintain your old friendship. Okay, so regression analysis, which is a subject of statistics, will be or is termed as one of the basic and fundamental tools for studying machine learning. I do not have any expertise in machine learning, but definitely I'm going to tell you what is the connection between regression analysis and machine learning. If you select any book on machine learning, and in the book, in the contents page, you can find that as mathematical prerequisite, regression analysis is there. And I have often seen in machine learning, some machine learning videos, that machine learning lecture videos, that regression, they start from regression. Okay, so regression is a fundamental tool which needs to be understood by all of us to get a good introduction to machine learning. Okay, so with this introduction, I'm going to start my topic of today's class. Regression analysis, or sometimes it is called linear regression analysis, and also specifically it is called simple linear regression analysis. Why it is called simple linear regression analysis, I'm coming to that point later on. But first of all, let me understand, what do we mean by that? What is regression analysis meant for? In 18th, near about I do not recall the exact date, but probably in 18th or 19th century, I don't recall the year. People were so much fascinated about a problem which came in front of them. The problem was that they suddenly started thinking of a particular situation where they try to deduce whether abnormally tall or abnormally short parents will have siblings with abnormally tall height or abnormally short height. And while doing so, and that problem is definitely a biological problem. Okay, and people had a misconception, and they thought that yes, if the parents are abnormally tall, their siblings will be abnormally tall. And if the parents are abnormally short, their siblings will be abnormally short. But later, this misconception, or you can say the myth, was broken by statisticians, and they found that no, this is not the case actually. Abnormally short parents or abnormally tall parents will have siblings whose whose height will tend towards the average height of general population. So it is not true that abnormally tall parents will have siblings with abnormally tall height or abnormally short parents will have siblings with abnormally short height. And thus the chapter regression came into light. Regression literally means moving backward. Okay, it is just the opposite word of literal progression. Okay, so you are regressing back. So you suppose there are two pillars, two long pillars are there, two abnormally tall parents are there. If like this, okay, so if their siblings are abnormally tall, then the siblings' height will increase. Regression analysis says that no, it is not. That will move downward, backward, and it will tend to the height of average population. So therefore, the word regression was actually brought into the picture. Okay, that is the meaning of regression. But when it was deduced, the regression was only confined in the domain of biology. But later, in the 19th century, it has been found that regression has a tremendous amount of applications in psychology. It has applications in physics, engineering, mathematics, and chemistry, and management. In everywhere, regression analysis has tremendous amount of application. And throughout during those researches, gradually it became an integral part of the subject called statistics. Nowadays, regression is taught in the course curriculum of statistics everywhere, all over the world. Okay, so regression has become the private property of statistics, but its application is not confined in statistics only. Its application is very broad. It has an application in a broader sense. So we are going to learn the fundamentals of regression analysis in today's class. Okay, that was a brief introduction. Now you can see I have used two words over here. One is called the input variable and another is called the response variable. Now in statistics, universally we call them input and response variable, but response variable is nothing but the dependent variables and input variables are nothing but the independent variables. Okay, so we have considered, to begin with, we have considered two variables. One is independent variable or input variable, which we denote by small x, and another is called a response variable or dependent variable, which we denote by capital Y. Okay, and we are considering an equation of the form like this: y equal to alpha plus beta x plus e. We name this equation as equation 1, where alpha and beta are parameters. Let us put my cursor on the term e like this. Okay, suppose the term e is not there. How does this equation look like? Y equal to alpha plus beta x. It is just like the equation y equal to mx plus c. So any of us can say that this equation 1 or this equation y equal to alpha plus beta x is the equation of straight line. Why? Because the power of both the variables on either side, that is the power of capital Y and power of small x, both are 1. And therefore, this equation is a linear equation, and a linear equation symbolizes straight line. Okay. What about this term, E? E is an extra term which is called the random error. And if we consider the mean of the entire structure, if I consider mean of on the left hand side and mean on the right hand side, the mean of E, mean of this error time will be assumed to be 0. Now, what is this error term? You will not understand until I finish to the end of this today's topic. Okay, until I go to the end of this today's topic, you will not understand the meaning of this E. But if at least I can say now that if I keep E as it is, if I omit E, this equation looks like a straight line equation. But if I bring E into the picture, then also it is a straight line equation, because E is a constant term and alpha plus E together can be considered as a constant C. So then also we can say that it is of the form y equal to mx plus c. But here definitely E has some sort of significance, which I shall come later on. Okay. Now this response, intentionally I have kept this response variable as capital Y and input variable as small x, just to distinguish between these two, that one variable is of independent choice and another variable is of dependent, or which is dependent on the variable, which is dependent on the independent variable. Okay, and this, but you have to keep in mind that there is no hard and fast rule between about the choice of these notations, capital Y or small x. Okay, you could have chosen capital Y and capital X for denoting the response and input variables, or you can uh, take the small for one and the capital for other. There is no hard and fast rule for doing that. Okay, the only important part is that one variable is response variable and another variable is input variable. And the equation of the form given in one is called simple linear regression. Why is it called simple linear regression? It is because there is another type of regression in statistics which is called multiple linear regression analysis. But this multiple linear regression analysis is beyond the scope of our syllabus, so I'm not going to discuss that in our course curriculum of BSM 301. To distinguish between this regression analysis which I'm going to study now from that one which I'm not going to study, they have used the term simple. So that's why it is called simple linear regression, just to distinguish it from multiple linear regression. Okay, let us now come to the point, what is regression and how to analyze it. Okay, so we shall try to understand this particular thing with the help of an example. Let us consider the example 1, problem 1. What I have written over here above is actually irrelevant in this particular case. Okay, let me read it for you. The use that can be obtained from a tire is affected by the air pressure in the tire. A new type of tire was tested for wear at different pressures with the following results. Pressures of tires are given, mileage are given in some units. But you know, in the study of correlation, units do not actually count. Okay, we are only interested about the values. But the important part in this particular problem is that the values are given. Values, it's a bivariate distribution. Two different values are given. One represents pressure and another represents mileage. In the above equation, it is mentioned that to analyze the regression model, we need two variables. One is called input variable and another is called response variable. But it has not been mentioned that if a bivariate distribution is given to you, which variable should be considered as input variable and which variable should be considered as a response variable. So since there is no hard and fast rule for doing that, so you can consider any of these two variables, pressure and mileage, as input and response. So if you think that, okay, let us consider pressure to be response variable and mileage to be input. All right, no problem. We will find a regression equation if possible. And if I think that, okay, mileage can be considered as response and pressure can be input, then also I can analyze the model, and if possible I can find the regression line also. Okay, important point is that there should be two variables. One of these will be input and another of that will be response. Another interesting part of this particular problem is that, you see, previously we have done lots of problems in schools and in your previous semesters that the linear equation or equation of straight line was given to you, and you plotted the figure by putting the points of the independent variable and thus getting gradually, consecutively, the values of the variable, which the values of the independent variable. So for each x you got y and you plotted the figure, you got a straight line or any other curve with respect to the equation given. Okay, but an equation was there and we actually found the values. Here the case has changed. In regression model, what we do, that we do not know what is the form of the equation. Okay, but the values are given. Some values, these are called observed values. We have observed it. We have taken the sample out of some experiment. Now we are going to deduce some sort of connection between the two variables. So the case is exactly reverse of the case which we used to do earlier. That is the main essence of regression, of studying regression model. In regression model, we are going to have some values, and from that values, we are going to analyze what sort of relationship is they are actually holding between them. Okay. But it is not always the case that the values, if the values are given like this, some sort of linear relationship will be hold in between them. This is not the always, this case is not universally true. If I consider this bivariate distribution, since we do not know what sort of relations, what sort of connection is there in between the two variables, we can assume any sort of connection between them. Okay. So there is a topic called curvilinear regression. So we can assume that maybe pressure and mileage are actually not linearly related, they are non-linearly related. It may so happen. If they are non-linearly related, how they are related? Exponentially related, or logarithmically related, or trigonometrically related? We don't know. So we can assume anything. But since we are studying the regression model, so we shall assume, and there is no uh, there is no I must say that nobody is actually nobody will object if I assume that, okay, if I forcibly assume that the two variables are linearly connected. I can assume anything. I can assume they are linearly connected or they are non-linearly connected. But the important point is that before I do studying, before I start my studying regression model between the two variables, I have to verify whether I can indeed analyze this as linear regression or not. If I give you the idea about how to analyze this regression model, and without verification, if you start doing the regression analysis, you will definitely get a sort of equation here, but that answer will be termed as a garbage answer. That will be invalid. Okay. So before we do analyze, before we start analyzing the linear regression model between the two variables in a bivariate distribution, we have to first check whether it is possible or not. Okay, so how to check it? How to check whether we can fit a regression model, a linear regression model between pressure and mileage? Or I have to check whether we can do so or not. So the first step is to plot the scatter diagram between the two. Okay, so I have plotted the scatter diagram, you see, and you know already I have shown you by in my previous class how to use Excel to draw the scatter diagram. In the examination, we will not be having access to the Excel. You have to do it manually, but Excel is a very good software which is often used in statistics. Okay, so I have done this sort of programming over here, and I have got a scatter diagram, a scatter plot of the mileage with respect to the pressure. Okay, here I have assumed pressure to be input variable and the mileage to be response variable. But what you are observing, what you are seeing in front of the screen, you are seeing that this curve is like this. Its curve is not at all a linear curve. Any layman who has idea about linearity can say that it's not a linear curve. If I have forcibly drawn a straight line like this, and you see how many points are above the straight line, how many points are below the straight line. Okay, so no way I can fit a regression model to the above problem. I cannot do so. So in this particular problem, we are unable to fit the simple linear regression model. Before fitting the linear regression model, if you do not verify by using scatter diagram whether you are allowed to do so or not, then your analysis will be totally wrong. So if someone gives me this particular problem, and if they ask me whether regression analysis is possible to the problem or not, I must say that yeah, maybe regression analysis is definitely possible, but not linear regression analysis. Maybe we know that this is kind of this scatter plot is kind of curve. So I must say that some sort of curvilinear regression is possible over here, not simple linear regression. But here in this particular class, since we are studying simple linear regression, so we shall answer to the problem in negative. We'll say that no, it is not possible to fit a simple linear regression model to the given set of data. Okay. Let us come to the problem number 2. Problem number 2 gives you two variables. One is small x. Intentionally, I have written small x, which we shall consider as input variable, and another variable is called the response, that is capital Y. And I have selected 4 points on either side. And you know, in regression and correlation study, the number of observations for both the variables must be same. I have mentioned earlier, if the number of variables are not same, then analysis cannot be done. Here, I am again going to first plot the scatter diagram to check whether linear regression analysis is possible or not. And if possible, let us try to find how to fit a linear regression model to the given problem. So again, I have taken the help of Excel and I have plotted the points over here. But now you can see, if you compare this curve to my earlier one, you will find that in this particular curve, although if I draw a kind of straight line like this, although not all the points will fall on the straight line, but they will be very near to the straight line. Some points will be above the straight line, some points will be very below the straight line, but will be very near to the straight line. So any layman again can say that, okay, previous was definitely out of question, but this particular problem, in this particular problem, we can at least try to fit a linear regression model, and we can check how the data are scattered around it. Okay, so in this particular problem, this fitting of linear regression is possible. How to fit the linear regression? In this equation 1, what is not known to us? You forget about E. Let me close this particular part, E, for the time being. If I say that y equal to alpha plus beta x is the equation, what is not known to us? The parameters alpha and beta are not known to us. If we can find the parameters alpha and beta in some way, then if we can find their values, this equation will be known to us. Okay, so in regression model, fitting of regression model is nothing but to find the values of these parameters alpha and beta in some way or other, so that we can get a definite structure of the straight line. So how to do it? Alpha and beta, these two parameters are not known to me. Okay, but since these parameters are not known to me, we cannot get a definite value for these parameters. So we can estimate them. And the estimated value of the parameters alpha and beta will be denoted by alpha cap and beta cap. And we are denoting this estimated value of the parameter alpha to be capital A, say, and estimated value of the parameter beta to be capital B, say. Now in the equation, what was the equation? If you note down in the copy, y equal to alpha plus beta x, alpha was not known, beta was not known. So what am I going to do now? I am going to fit all possible points for the variable small x, which is the input variable, and I can plot in place of alpha is its estimate capital A, and in place of beta its estimate capital B. And I will get this kind of relationship over there, A plus B xi. And for each of these values x, for each of these i's, the value of capital Y also keep on changing. And therefore, we will get an equation like yi equal to A plus bxi. Now, in this equation 1, there was a term like E. E is called the random error. Now, for each xi and for each yi, this error will change. Suppose I am keeping E on the right hand side. Okay, so what will be the form of E? The form of E will be y minus alpha plus beta x. Okay. Now, if I keep on changing the values of xi's and yi's, these e's will keep on changing. So therefore, to analyze alpha and beta, to analyze this regression model, I have written here each value of E to be epsilon I. Epsilon I is the error term corresponding to the ith value. Okay, so epsilon I can be denoted as yi minus A plus bxi. Let me write this equation as equation 3. What is epsilon I? Is the ith term of the variable E from equation 1. and represents error that would result from using estimators capital A and B to predict the response at input value small xi. It is reasonable to estimate alpha and beta in such a way that these errors are minimized. Now, epsilon I is the error term. I am pretty much sure that you have not understood what do we mean by error term here. But whenever I'll be solving a problem below, you will gradually understand what does it actually mean. But we have to do one kind of mathematics over here. What is that mathematics? I have to choose this alpha and beta, the estimate of this alpha and beta in such a way so that this error term is very small. I cannot just put arbitrarily the values of alpha and beta. If you put the arbitrary values for alpha and beta, the error term will increase. But I have to do the calculation in such a way so that this error term is minimized. How can I minimize this error term? What is the way? What is the way out? The way out is take the summation on both the sides. Okay, first of all, you take the square on both the sides. So epsilon I is yi minus a plus bxi. If I take epsilon I square, we will get yi minus a plus bxi whole square. Now take the summation on both the sides. That summation, I goes from 1 to n, epsilon I square is called the sum of squares of errors. I shall choose my alpha and beta in such a way so that this sum of squares of errors is minimized actually. And this sum of squares of errors can be minimized by using the method of least square. And the method is also sometimes known as least square. And since we use a method of least square to estimate alpha and beta, so this estimated value of capital A and capital B of alpha and beta are called least square estimators. On day after tomorrow, I'm going to discuss in details how to use method of least square to minimize this sum of squares of errors to get the estimate of alpha and beta. But in today's class, after a long time I'm taking the class, and it's in the first class I do not want to get into the theoretical detail of this particular mathematical analysis, because otherwise you will find it non-interesting. Today I'm going to stick to the problem only. Okay, so here I am going a smooth jump, and I'm saying that okay, let us not discuss how to use method of least square to estimate alpha and beta. Let us suppose somehow it can be estimated for the time being. And if we can estimate, what will be the estimated value of alpha and beta? So I have written here in this green colored portion the result only. But that result will be in detail analyzed in our next class. So beta cap is the estimated value of beta. Okay, and it can be found out by the following formula. Summation over I goes from 1 to n, xi minus x bar multiplied by yi minus y bar. And this thing will be divided by summation I goes from 1 to n, xi minus x bar whole square. For our purpose, we have used a kind of notation over here. The numerator here in this particular case has been denoted by sxy, and denominator has been denoted by sxx. But you do not concentrate on the notation. Notation can be changed. Okay. But what is this denominator term? This denominator term is not new to you. This denominator and numerator term is actually known to you, familiar to you. If I multiply this numerator by 1 by n, the numerator becomes covariance. And if I multiply this denominator by 1 by n, this becomes variance. This is variance of x, and that is covariance between x and capital Y. Once this beta cap is known to you, I can use the value of beta cap to estimate alpha. So I have written here alpha cap is equal to y bar minus beta cap into x bar. And y bar and x bar are the arithmetic means of the variable x and variable y. This entire part, which is here green colored, this entire portion can be done using method of least square, which will be discussed in details in my day after tomorrow's class, not today. So we have got our estimates of alpha and beta. And once the estimates are known, the regression equation capital Y equal to alpha plus beta small x becomes small y equal to alpha cap plus beta cap into x. Here I am writing small y is because now we get different values of small y. You can consider capital Y to be the random variable, which will have different values small y. So here I am denoting, I'm putting small y to show that the depending upon the value, different values of x, and since the estimated value of alpha and beta are known to me, the values of y will also keep on changing. But where this e term, since we have used the method of least square, and method of least square try to minimize the sum of the squares of errors, that e term will vanish. So ultimately we get this equation number 5, which is called the regression equation, where as usual beta cap denotes the slope of the line and alpha cap denotes the intercept of this line. The rest is very simple. I have tabulated the values of xi and capital Yi over here, okay? And as per our requirement in the formula, we need xi minus x bar multiplied by yi minus y bar. So I have calculated the arithmetic mean of the variable x and arithmetic mean of the variable y. And I have taken the difference of this mean from each of the points of x, which is denoted by xi minus x bar. And I have subtracted the mean of y from each point capital Y. Okay, and we have got these values. Then I have multiplied these two terms and we got this column. We need the summation of this column. So I have got the summation as 16.75. And similarly, xi minus x bar whole square has also been calculated, and that its summation has been tabulated. After getting all these values, I have used the formula of beta cap, and I have divided, since beta cap is sxy by sxx, I have put the values over here 16.75 and divided by 8.75. So the estimated value of beta is coming out as 1.914, and similarly the estimated value of alpha is coming out as 2.48573. Okay, and thus my regression equation becomes y equal to alpha cap plus beta x, which is 2.49 plus 1.91x. Let me show you something. Okay, let me show you, share this Excel file with you. In this Excel file, I have, probably you are able to see it. In this Excel file, I have I have plotted all the points which is given in the question, small x and small y. Okay, I have selected them. All the points, entire table is selected, and I'm going into this part, this section called insert. In insert, we have got this scatter. From there, I'm considering the scatter plot. The scatter plot is coming out as this, which you have already seen. After this, I am moving my cursor and to this particular point or this particular point, and I am putting a click over here, double click. All the points are getting selected. Like if I do so, the points are getting selected. Okay, then I am clicking on the right button of the mouse, and this drop down menu is coming. From this drop down menu, I am choosing this section, add trend line. Linear, this is by default selected. Okay, and since we are actually analyzing the linear regression model, we shall not change it. We will move our cursor to this particular section, which is known as display equation on chart, and I have clicked on it. Close this, and bingo, this regression line is being shown over here. This is my regression line, and you see I have got the same thing, 1.914x plus 2.485. That was those are the values of alpha cap and beta cap, which we have found already. Okay, so that's how we can find the regression equation by using the Excel software. Let us go back to our note, which I was discussing. So we have seen that this regression equation can also be found using the Microsoft Excel, and Microsoft Excel is a very useful software. You don't have to go for statistical software like R or SPSS or any other software. If you have Microsoft Excel, we all have access to it, so we can easily you take the help of it to solve to do the statistical analysis. So our regression equation has been obtained. Now I am again putting the values in the chart, X and capital Y. These X and capital Y are these capital Y's are called the observed values, which has been obtained directly from the system. But after getting the values, I have analyzed it and I found the regression equation. This is a possible regression equation. If this can be the regression equation, what will be the change in the values of Y corresponding to the values of X? So I'm individually putting the values of X over here, one after another. And I'm getting these values for small y corresponding to the regression equation. And if you look very carefully, I have highlighted them. There is a minor difference between the two values, observed values and the theoretical values. Here the observed value is 4, here the theoretical value is 4.4. Observed value is 7, theoretical value is 6.31. Observed value is 8, theoretical value is 8.22. Observed value is 12, theoretical value is 12.04. And the difference of these two values is called the error term, which I used in equation 1. So some errors will be negative and some errors will be positive. You take the sum of that, and if you take the arithmetic mean of this, that arithmetic mean of these errors will be very nearly equal to the 0. And I have plotted here the chart which I have obtained using the Excel sheet. These are my scatter diagram, and this is my regression line. This point has not fallen into on the line. This is above the line. Other 3 points have fall on the line. Okay, so this is my regression equation, desired regression equation. Why regression is a path to study machine learning? Briefly, I am saying that what is the basic objective of regression? Initially, in the software, we used to feed the software with a program, and if we can feed the software with a program, the outputs, the software must give me some sort of outputs. In regression, we do exactly the opposite. What we do? We feed the software with the outputs, okay, the observed values, and the software gives us the program, the equation. Okay, you can think of the software as a YouTube channel. You are surfing the YouTube channel. Okay, so outputs, you can consider a bivariate distribution. Day and night, you are surfing the YouTube with new movie trailers. Okay, so the trailers, the trailer numbers are the one sort of variable, and time is one sort of variable. What YouTube will do, the inbuilt software YouTube will do, he will try to analyze and try to find out whether your choice or your timing has some sort of linear relationship between them or not. And if he can find it, if he can fit it, he will give you many more hits of upcoming trailers of the movies, upcoming movies, so that you can hit on them. So that is how, and this is machine learning. This is nothing but machine learning, where regression is used as a basic tool. This is this much for today. In day after tomorrow, we are going to discuss many more things about regression, further details on regression analysis. Okay, so for today, bye.